Hello there, mathematicians. Today's objective is students will be able to calculate weighted averages. That is a vocab word. Okay, get that down. All right, a weighted average. I want you to start off by just thinking about your own grades in our math class, okay? You should know this, but tests are worth more than like homework or mastery quizzes. They count for more of your grade, a higher percent of your grade, okay? So a weighted average is a situation like this where some items, and we're just going to start off broad, some items are worth more, and you're going to have to write small. Okay, we're going to cram a lot into this little space here. Some items are worth more than others. Remember, we use THAN because we're comparing things. We're not talking about time. Okay? So, I want to go over, and again, keep in mind, a real-life example that you should know, tests in our math class are worth more of your grade, a higher percent of your grade than, say, quizzes or homework. Okay? Let's go over a brief example. So, you can do a squiggly line in your notes. I want you to just do something that we've talked about a lot. Quiz 1, let's just say you take quiz 1 and you got a 90%. Okay? Quiz 2 you took and you got a 100%. Okay? Calculate the average. You should be able to do this in your head. Okay? The average score for these quizzes, what is it? Okay? You should have gotten 95%. Right? You just add up the 2% and then divide by how many there are. Okay? So 90 plus 100 equals, divided by 2 is 95%. Now, here's the difference. Here's where weighted averages come in. Okay? If tests, and I'm just making this up, this could be for like a college class or something. If tests are worth 75% of grade, and let's just say quizzes, again, think as you write this, are worth, let's just say there are only quizzes and tests, so are worth 25%. Okay, so this is just a hypothetical example. All right, so say, with this example, say you had a test score, and again, write this all the way over here to the left, test score of, let's just say, 80%, and a quiz score of, let's say, 90%. Okay. Can we just say that the average would be, if you add those up and divide by 2, can we just say that the average is 85%? Think about that. The answer is no, we can't. Well, why can't we? Why can't we just add those 2 up and divide by the 2? We can find the average. Okay? Here's the reason right here. Tests are worth more. They're worth a higher percent of your grade. When you just calculate the average by adding them up and divided by 2, you're saying that tests and quizzes are worth the same amount. And it just says right here, they're not. Okay? So I want you to make a note right here that something about you cannot, let's just say, do regular average because tests, I'm going to shorthand this because I'm about out of room, tests worth more. That is clearly not a complete sentence, but I'm out of room. Again, tests are worth more, so you can't just find a regular average on that. Okay, use cups and read example 1. Okay, so Polly has 7 dogs. 2 of them eat 3 treats per day. So you guys, right when I read this, those two things have a relationship. So I like to draw an arrow to just show, okay, the 2 dogs eat 3 treats a day. Okay, 4 of them eat 1 treat a day. So 4 of them eat 1 treat a day. And that's 1 treat a day each. Okay, 1 of them eats 5 treats a day. On average, so here we go. Right away, we should be thinking add, count, and divide. How many treats, okay, does one of our dogs eat each day? Okay. The question is essentially asking us, how many treats does each dog eat per, or each, but per day? So this is really important that you can understand. This is all that's really asking for. All of our dogs, on average, how many treats do they eat per day? Okay. So we could do this. First of all, let's answer this question: is it weighted or not? Do we just find a regular average, or do we need to find a weighted average? Think about that. Okay. It is weighted. Okay. And the reason why is because some dogs eat more treats than others. Okay? If you think back to that test example, right? Tests are worth more than quizzes. Well, some dogs are eating more treats than others, and you have a different number of dogs eating those treats. Okay, so you have to take that into consideration. Okay, now we could do this the long way. Okay, so I'm going to just show this down here the long way. I'm going to put it in the corner because we're going to learn a better math way of doing it. 2 of the dogs eat 3 treats a day. So we could say, oh, well, dog 1 eats 3 treats. Dog 2 eats 3 treats, right? That's what this first part says right here. 4 of them eat 1 treat a day. So you'd be like, oh, plus the 1 dog eats 1 treat. Again, 4 of them, right? So plus 1, plus 1, plus 1. And then 1 of them eats 5 treats a day. So we could do it the long way, add all those up, and divide by the 7 dogs. Okay? But there's a better way of doing it. When you have repeated addition, you can weight that. You can show, okay, and let's start by getting this down. I'm going to change colors. Okay, if you look at the number of dogs, okay, and you multiply it by the number of treats, okay, and then do the same thing for all the different groups. So 2 of the dogs, right? 2 of the dogs eat how many treats? 3 treats a day. Okay. Plus, because again, we're finding an average, so you just add them up. 4 of the dogs eat how many treats a day? 1 treat a day. Okay. Plus, are there any other groups? Yeah, 1 of them, 1 dog eats 5 treats a day. Okay. This is showing the exact, these two things are showing the exact same thing, right? 3 plus 3, you can show as 2 times 3. 1 plus 1 plus 1, I think plus 1, you can show as 4 times 1, okay? Now, what do we need to divide by? Okay, so I'm just realizing quickly I made a mistake right up here where we wrote treats per day. The question is asking us how many treats does 1 dog? So that's treats per 1 dog. Okay, so again, let's reread that because I made a silly mistake in writing that. The question asks, how many treats does 1 dog, and it's eat each day, right? So we're talking number of treats per 1 dog. Okay, so we calculated right here, this numerator is the number of treats, but now we need to find out per dog, per 1 dog. Okay. Well, how many dogs are there? There are 7 dogs. Okay. So go ahead and multiply the numerator, show that work, do it on your calculator, write what you get, and then divide it by 7. So hit pause, do that now. Okay, you should have gotten, for number of treats, you should have gotten 15 treats for the 7 dogs. And if you divide that out, okay, and I'm going to write it up here because I'm out of room, you get about 2.14. The units are 2.14. Again, what was the question asked us? It was asked how many treats for one dog, so it's 2.14 treats per dog. And we know that that's talking about just one day. Okay, treats per dog each day. Okay. Now, you may be thinking, are you actually feeding each dog and you're breaking up into 0.14 of a treat? No, but this is just representing the average for it. Okay, so you don't have to worry about the rounding for it in this case. Okay, go ahead and use cups on number 2. Okay, so in a certain advisor there are 10 14-year-olds. Okay, there are 8 15-year-olds. Again, I'm just showing these relationships, and 2 16-year-olds. Okay. Now, the other thing that you could do is, instead of just doing the arrows, you could write underneath these, like you could write 10 for the 14, 8 for the 15, and 2 for the 16. The question is asking, what is the weighted mean age of these advisory members? Okay. So right away, the weighted mean tells you have to do something, a little bit more. You can't just add them up. So a common mistake is for students to say, oh, you have a 14-year-old, 15-year-old, 16-year-old. So they do 14 plus 15 plus 16 divided by 3. Okay. The problem with that is you're not taking into account how many girls there are. Does it say girls? No, how many kids there are, I guess. Okay, in each age group. Okay. So this is a weighted mean, and the reason why is because, so it is weighted, and we can make a note, okay, that there are a different number of girls in each age group. Okay, so there are different, and I'm going to abbreviate for space, different number of girls. I guess this one, so let's just say kids. I keep thinking girls, it's not. Different number of kids in each age group. Okay. So we have to take that into consideration. Now, it's important for you to think, if we had 3 kids, one was 11, one was 15, one was 18, and we said, what's the average age? What would you do? You would add up those ages, right, the 11, 15, 18, and you would divide by the number of kids. So that's all we're going to do here too. And let's make that note. So add up ages, and we're going to divide by the number of kids. Okay. Now we have to take into consideration, okay, how many kids are in each group. So for the 14-year-olds, okay, so for the 14-year-olds, so if you want, you can make a note of age times the number. And again, it doesn't matter whether you do number times age. So 14-year-olds, how many were there? There were 10, right? It's average, so we're going to add them up. Let's see, the 15-year-olds, how many were there? There were 8. Add up. 16-year-olds, how many were there? There was only, how many were there? 2 16-year-olds. Okay, so that'll tell us all the ages if we add them up. Now we have to divide by the number of kids. So count right now, how many kids are there? Well, 10 and 8 is 18, and 2 is 20. So hit pause, do the numerator, figure out what is the average age of these kids. Hit pause, do that now. Okay, you get the average age. I believe you get 14.6. Okay, and we should write years old because it is an age. Okay. All right, if you have any questions, make sure you hit pause and make a point in your note with a question mark about what questions you have. Okay. All right, you're going to use cups and read number 3. So go ahead, hit pause now. I want you thinking about how would you set that up. Okay, hit pause now and do that. Okay, let's think through this one. This one is a tricky one. Again, if you have not really given this a shot and thought it through and maybe even written some things down in pencil, hit pause and try it again. You have to try these tough problems on your own. Okay. All right, Miss Moran ran an average of 8 miles during a 12-day period. So right away I see something really important. Average. Okay. What was the average? The average was 8 miles. So you guys right away on this problem. Okay. I'm saying that the average, I know the average is, so equals, the average is 8. It says it right there. Okay, during a 12-day period. That's another total. Okay. During the first 10 days, okay, she averaged 7 miles. How many miles did she run total during the last 2 days? Okay. Well, how would we figure out the average of miles run per day? Okay, well, we just said something really important. We're looking for the miles that she ran per day. So we need to divide by what? By the days. Well, how many days did she run? It's right there. She ran 12 days. Okay. So again, that's tricky, but you have to think it through. We're asking for how many miles did she run total during the last 2 days. Well, we're really wondering miles per day. We just need to know the last 2. Okay, so it's miles divided by days. Now, what's given to us? What other information? Well, during the first 10 days, she averaged 7 miles. So what we can do is we can say, oh, we take the number of days, multiply it, because we weight it by the number of miles. Okay? So during the first 10 days, how many miles did she run during the first 10 days? 7 miles, and we should add on here 7 miles per day. Okay, in addition to the per day right there, again, it's 7 miles per day. Right here, again, just to clarify the wording, because the wording is really important. Miss Moran ran an average of 8 miles. I want you to add the word daily. Okay, which really means the same thing as per day, right? 8 miles each day. Okay, and again, the question is asking how many miles did she run total during the last 2 days. So again, we can do the 10 days times the 7 miles per day for those 10 days. And then we add, how many days are left? Well, there are 2 days left, right? Because there's a total of 12. And do we know how many miles she ran each of those 2 days? No, we don't. So I'm just going to times it by the miles that she ran each of those 2 days, which we don't know. Okay. Now, it looks like a tough equation, but when you simplify it, it actually gets pretty easy. So we can do 10 times 7, so I'm going to do a squiggly line. 10 times 7 is 70, plus, what's 2 times m? Well, 2m, over 12 is equal to 8. Okay. Now, the entire side with the variable, right? The variable's on the left. The entire left side is all being divided by 12. How do we do that? We multiply the entire side by 12. And I'm going to show as a fraction because then you have 12 in the numerator, 12 in the denominator. That will cancel. Whatever you did to one side, you have to do the exact same thing to the other. Rewrite 70 plus 2m is equal to 96. Okay, and then it's a two-step equation that you can solve. So go ahead and solve that equation now. Okay, when you solve this, you get m equals, what do you get? Let's see, that'd be 13. Okay. Now, you may be thinking, so the question is that the answer? The miles is equal to 13. Let's go back and read the question. How many miles did she run? And I hope you guys caught that when you were using cups. Did she run total during the last 2 days? Keep in mind, M, what does M represent? M represents the miles that she ran each day those last 2 days. If we want to find the total for those last 2 days, we have to say, well, for 2 days, she ran how many miles each day? Again, the question is, for 2 days, right here, Miss Moran ran how many miles each of those 2 days? She ran 13 miles each of those 2 days. So how many total miles did she run? Well, you have to do that 13 that she ran each day times the 2 days. So the answer is, and you can make a note of this, 2 times, so again, 2 days, she ran 13 miles each of those 2 days. So the grand total is, how much did she run total? 26 miles. Again, total in those last 2 days. That's not 26 miles per day. That's 26 miles total in those last 2 days.